Good morning everyone. I'm Chitra from Shizuoka University. My poster title is Theoretical Study of the Impact of Donor-Acceptor Pair on Tunneling Current in Silicon Nanodiodes. Low-dimensional silicon devices plays a major role as the device miniaturization continues. So motivation of this work is to utilize these conventional dopants for enhancing the BTBT current transport in silicon P plus N plus diodes at the atomic level. Mainly this work is simulated using the quantum ATK software, which is based on the first principle simulation. So this figure shows the cross-sectional view of a silicon nanowire with dimensions. Here the dopants are inserted substitutionally. All dangling bonds are passivated using the hydrogen. This geometry is optimized before doing any calculation, and from this we make a device, and in this which is based on P plus N plus leads. These leads are electrostatically doped, and all for devices the current voltage characteristics are calculated based on a non-equilibrium Green's function method. This is the basic tunnel diode IV characteristics that is observed, and here we could see that forward bias having an NDC, reverse bias have the high current, which is consistent with the basic tunnel diode reported even 50 years ago, with some exception that there is no phonon contribution is involved in this. At the first study, we vary the central region, and because of this we calculate the IV characteristics for these different central region length. So it is clearly observed that the tunneling rate is increasing for the central region length decrease. So which is clearly seen from the current voltage characteristics observed here. Now we introduce the dopants in the central region at the different distances between the dopants, and IV characteristics are calculated, and this is the reported IV characteristics for all these configurations. And here which clearly shows that the dopant introduction increases the current level with the 2 order of magnitude. Here the enhancement is also confirmed through the representation of LDOS, which shows clearly the modification in the band edges, and where the tunnel barrier is also very narrower, which also in turn increasing the current after introduction of the dopants. So from this I conclude that we are able to observe the basic tunnel diode characteristics, and also after introduction of the discrete dopants, here these donor acceptor clearly enhances the current level. And also this kind of a current level enhancement is possible because of the electric field modulations introduced by these dopants, and the energy modifications also enhances the current. So which can show the new functionalities in this kind of BTBT devices. Thank you for your attention.